Hello, okay, today what we are going to talk about is just the basketball. What do I mean by basketball? We are going to shoot something called a three-pointer. So we are going to shoot a ball from approximately 6 meter point 75. I mean, we are using the FIBA European rule. And how about the motion of basketball and how it's connected with physics? So first of all, we need to appreciate just the formula of acceleration of the ball. As you can see, is given by three terms. The first term is connected with gravitational fields. This is obvious that the gravitational field is just acting on a ball to make this fall down. The second is less obvious. This is the Magnus ball, so the Magnus force, so the force which is created when the ball is rotating. This is why we are shooting, while we are shooting the ball, we are rotating this backwards, and as a result you should obtain a force which is making the ball fly a little bit above the regular trajectory. And the last term is obviously the air resistance, usually which is not concerned in the normal exercises we are doing in school or at the university. So what is my strategy? Is very simple. I would like to solve this equation because this is a differential equation, since a is just the second derivative of displacement, but I'm going to do it as simple as I can. So there is an Euler formula. I'm just multiplying by some small dt to obtain this. And this is the picture. There is a guy, a player. He is going to shoot the ball from 6 meters 75 centimeters. Of course, he is holding the ball approximately 2 meters above the ground. In my case, it's going to be only 1.7 meter, but it doesn't matter. Let's approximate to take it 2 meters. And there are three important initial conditions. There's the initial velocity, so the velocity of the ball, the elevation angle, this theta, and omega x. I mean, this is just the angular velocity of the ball, so initial angular velocity of a ball. And our player is equipped with something called the standard deviation, because it's not the ideal player. He's shooting the ball with some deviation, so sometimes there's additional rotation in, for example, around z-axis, sometimes something about y-axis. In other words, when we are shooting the ball, sometimes there is some noise about the ball. And what is my aim? My aim is just to investigate this noise and how this initial noise is influencing three things: the variance of the distance between the point when the ball is hitting the basket and the center of the basket, so with the variance, independence of theta, also the score depending on theta, and the initial velocity, because maybe for some thetas, for some angles of elevation, the velocity would be enormously high and it would be impossible to shoot a ball like this. And my second aim is just to pick the theta for which this initial standard deviation is having the least influence. I mean, for which, even if something is wrong with our technique, or maybe is going to be a defender next to us, we are going to shoot the ball with the biggest efficiency. Of course, how about those initial parameters? For each elevation angle, I would need to find it myself, but I just use a trick. I use a Bazin-Hoping algorithm for finding optimization. We've got the two parameters, v0 and omega x, for each elevation angle. And what I'm doing, I'm just using heuristic optimization algorithm to find the minimum value of this. So the minimum value of the point at which the ball hits the basket and the center of the basket. So without any noise. So I'm picking one shot without any noise. I'm trying to pick the best v0 and omega x, and later I'm adding the noise and calculating, for example, 100 or 200 of realization of this random variable. And basically I just pick all those parameters which are closely related to reality, and let's find what happened.